this is the last chapter of the semester, and it is going to be on matrix and how to use matrix for multiple different things. The beginning of the chapter is not hard, and then when it gets to application, it gets pretty challenging because you have never seen it before. So stay with me the first few sections for review. This one, I couldn't find that link, and I can't click on it, so I can't show you the video, but it's the same video we watched last year about how to add matrices and multiply matrices. So if you still remember from last year, it's the same idea. So matrix is an array of numbers. Array means that you have a lot of different numbers kind of written in order. And so, for example, this is a matrix A, and it has rows and columns. Rows always goes horizontal, columns always go vertical. So how many rows does it have? 2. Yes. So we always start from the top to the bottom. So row 1 and row 2. How many columns does it have? 3. Again, we go from left to right. So column 1, column 2, and then column 3. All right, so now when someone asks you what is the order of the matrix or what is the size of the matrix, we always tell them whatever the row number is and the column. So this one would be what by what? How many rows by how many columns? 2 by 3. Yes, correct. All right, so let's go ahead and have you practice 1 and 2. How many rows, how many columns, what is the size of the matrix? All right, let's start with Ashley. Number 1, how many rows? McKenna, how many columns? 2. Caleb, what's the size? 3 by 2. Mark, number 2, how many rows? Trey, how many columns?
1.
Okay, Andy, what's the size? Size?
2.
Yeah, 2 by 1. All right, now the next thing is a matrix element. A matrix element is a number in a matrix. And we also define it by row and column. Notice that when we're talking about a matrix, we always use capital letters. But if we're going to talk about the element, we use lowercase letters. So A12 means row 1, column 2. So the little a means a number that's inside that matrix, and what number that is row 1, column 2, because it says A12. A12 means row 1, column 2. So let's look at how we're actually going to name these. So the first number in the element is always the row, and then the second number is always the column. So this 1, 1 means row 1, column 1. 1, 2 means row 1, column 2. Okay, so what do you guys think the next one is? A13, yeah, correct. And what about this one here? A21, yes, row 2, column 1. Okay, so go ahead and finish filling that in. All right, now we're going to actually perform some operations on the matrices. First, we're going to add them together. Most of the matrix practices are not hard. It's just your attention to detail. You cannot make small mistakes because they create big mistakes later. All right, A plus B A is 2, 3, 4, 0, -1, -4, plus B is -3, 1, 6, 2, -3, 7. So it's very easy. You add the similar positions together. So adding the two matrices just means take the number from the same position, add them together. So 2 plus -3 is -1. And then the next position would be A12. That is 3 plus 1, which is 4, and so on. And until you add up the respective positions together and you have the matrix. Good? Easy? All right, so let's go ahead and have you guys try the following: A minus B. And then the last one, 2A. 2A just means multiply every element by 2. Okay, so finish 2 and 3, and let me check. A minus B is 5, 2, -2, -2, 2, -11. And then 2A is 4, 6, 8, 0, -2, -8. Okay, next, zero matrix. Zero matrix is very easy. It just means the matrix is all zeros. So, for example, a 2 by 2 zero matrix is going to look like this. So 2 rows, 2 columns, 2 by 2. Zero matrix looks like that. Additive identity. So any matrix plus the zero matrix is going to equal what? A. Additive inverse. So if A matrix plus B matrix is equal to 0, then what does that mean about A matrix and B matrix? They're opposite. Yeah, they're opposite of each other. So every element in there is the total opposite of the other matrix. So we call that. Then B is the additive inverse of A. So for example, if I have the matrix 1, 2, 3, 4, and I add to another matrix, and that matrix somehow got me a zero matrix when I add them together. So what's in the missing matrix? What are the elements? -1, -2. Yeah, -3, -4. All right, next. So adding and subtracting is very simple. It's just please be careful. Don't make small mistakes. All right, matrix multiplication. All right, this is where you must follow my example, and please don't create your own, because one small mistake leads to many, many more mistakes later. Okay, when you're multiplying A and B, so the position matters. A is on the left of B, then A has to be on the left of B. Okay, so do not switch them. It's not the same as numbers. Numbers, you don't care about the way you multiply, but matrix, you do. All right, excuse me. A is on the left, so A matrix is going to go on the bottom left. So if you go home and watch that video that's on the link, it has a really good animation of how to multiply. All right, A is on the bottom left, and then B is going to be on the top right. And then what you're going to do is in that space, kind of think of it like this. You have this matrix here, this matrix here. They're going to kind of cross, and then that space that they share or they intersect is going to be your final matrix that you multiply. So this is where you need to now draw some lines. I'm going to draw a straight line through the 2 rows for matrix A and a straight line through the 2 columns of matrix B. And then now you're going to actually multiply and add the elements. So this row and this column are going to produce the answer for A11. Okay, hopefully you still kind of recall from last year, or else watching the video would make a lot more sense. So you're going to take the first element of the row times the first element of the column. Kind of do that on the side. Then you're going to add the second element of the row times the second element of the column. And then you do that again to the third element of the row and the third element of the column. Add that together. So 2 plus 0 minus 3, that's minus 1. So minus 1 goes in here. Good? Okay, and then the next one is the same. So you're going to take this row again, but you're going to multiply by this column. And then you're going to do the same thing. I know you can probably do the numbers in your head, but you got to be careful not to make mistakes. Especially a lot of times we take 0 times a number and then we want to say, like 0 times 2, we want to say it's 2 instead of 0. So please be careful of that. So if we were to try to find A12, so it's going to be 2 times negative 4 plus 1 times 2 plus negative 3 times 0. That is negative 8 plus 2 plus 0. So that's minus 6. All right, go ahead and find the other 2 leftover elements. Okay, so this one is 2, 2, the last 2 numbers. So most of you went on to find this next one, product of A, B. So remember A goes on the bottom left, and then B goes on the top right. So this would be the final matrix, and so you draw lines, and then this row has to multiply this column, and you start, and then you'll see that you'll multiply them together, except the column does not have enough numbers. So you cannot actually multiply these together. So this is not possible, so can't do it. Now, you don't want to get to the point where you do try it and then realize you cannot do it. You want to be able to predict that. And that has a lot to do with the size. So let's look at the size of matrix A. What is the size of matrix A? 2 by 3. 2 columns, 2 rows, 3 columns. What about B? Yeah, 2 by 2. Good. So in order to be able to multiply, the 2 numbers that is in the middle, or the column and the row of the next one has to match. Okay, so you're writing A, B like this, A and then B. So the 2 numbers in the middle have to match. If they don't match, then you cannot multiply. And so this is our multiplication rule. You can only multiply matrices A and B if A is a matrix with size m by r, and then B is r by n. So then you can see that the 2 numbers in the middle are matching. This is the only way you can multiply. Now, if you do multiply them together, then we want to also predict the final size. The final size is going to be m by n. So this would be the final size. So first, we want to be able to predict, can we actually multiply? Second, we want to predict the final size when we do multiply. Bless you. All right, so let's look at a practice one really quickly. Can we multiply them together? Okay, what's the size of A? 2 by 2. What's the size of B? 2 by 3. Can we multiply? Yes, because the numbers are the same. What's the final size? 2 by 3, correct. So you should get a 2 by 3 at the end. All right, go ahead and multiply. Let me know when you're done. Okay, let me give you the answer first for those I did not check. The answer is 6, 2, negative 10, 31, 5, negative 7. Oh, I'm sorry, not 6. I did this again. Sorry, 22. All right, next. So we're going to start doing this thing called a identity matrix. And identity matrices are always square. So what's going to happen is you have a square matrix, and the way identity matrix looks like is that it has 1 in all the diagonal. And when I say diagonal, it's going to be starting from the top left all the way to the bottom right, not the other way around. Okay, so 1, 1, and all the way down to the other corner. It's all ones. And then everything else is all 0. So only 1 down the diagonal, everything else is 0. So this is called the identity matrix. Now, identity matrix is very interesting because when you multiply any matrix to the identity matrix, and then you write identity matrix as I, when you multiply any matrix to the identity matrix, you get itself back. For example, if you take the A matrix and you times the I matrix, which is the identity matrix, it's actually the same as taking I matrix times the A matrix. So for identity matrix, because it doesn't matter which way you multiply, you're always going to get itself back. This is the only one you can multiply in both directions. When you multiply A and B matrix together, if they're not identity matrix, you cannot actually reverse them. But identity matrix is possible. It's like a 1. You can multiply by 1 and get itself back. Now, this is a little bit tricky. If you have 2 matrices, you multiply them together, and then you get the identity matrix. Then, okay, so let's kind of talk about it in a real number sense. If you have a 5 and then you times some number and you get 1, what is that number? 1/5. Now the trick question, 1/5. Okay, so what's the relationship between 5 and 1/5? Reciprocal. Yeah, they're reciprocal, not inverse, but they're reciprocal. Now, in a matrix world, we would actually call that inverse. So basically, if somehow I take A times B, and then I get the I matrix, which kind of in a way means 1, then that means A and B must be in a way where we are able to kind of inverse them and get an identity matrix. Okay, so A matrix times its inverse will always give me the identity matrix back. That means if A times B is also getting me the identity matrix, then B must be the inverse of A. So kind of like the logic, if A equals B, B equals C, then A must equal C. Now some vocab. So you got to memorize these vocabs. If a matrix does have an inverse, we call that non-singular. If a matrix has no inverse, we call that singular. So singular, non-singular. What does singular mean? Huh? No inverse or yes inverse?
No inverse.
No inverse. So if it does have an inverse, we call it non-singular. Okay, you got to memorize these vocabs as you go, so they will come up later. Okay, check to see if the 2 matrices are inverse of each other. How are you going to see if A and B are inverse of each other based on what we just talked about? You multiply them together. Okay, what are you looking for? Yes, if they are inverse of each other, then when you multiply them together, you should get the I matrix, the identity matrix. Okay, so if A and B are truly inverse, then we should get I. The question is, do we? So you're going to multiply them together and check. Did you guys finish? Yes? Okay. So let's just vote. How many people say A and B are inverse of each other? Okay, how do you know? Okay, so A times B gets me the identity matrix. Yes, that's correct. So A and B are inverse of each other. So let me ask you a question. Is A a singular matrix? Okay, don't say anything. Talk to your partner. Is A singular? All right, let's vote. How many people say yes, A is singular? How many people say A is not singular? Okay, that's correct. A is not singular because if it's singular, it has no inverse. Clearly, A and B are inverses, so A has B as the inverse, so A is not singular. Huh? Okay, to be singular, it means you have no inverse. Right? A times B gets you I. That means A and B are inverse of each other. Right? So A's inverse is B. So A does have an inverse, which is B. Yeah?
Oh, I remember the thing. Like, how to know the inverse? Like, they switch, and then there's.
Oh, yeah, that's the, yeah.
I found out.
That's the next thing we're going to do. So A is not singular. Okay, let's look at the next question. Let's make sure we understand what it means. Prove that matrix A is singular. Prove that matrix A is singular. What are we proving? That it has no inverse. That it has no inverse. So the question is, how do we do that? So singular means no inverse. We have to prove that there's no inverse. How do you prove that something has no inverse? Huh? Okay, let's have you and your partner try to think of a way. So it's better that you think now than, later on the test, I will ask you some kind of out-of-the-box questions. Then you don't want that time to be the only time you think about it. So how do you prove that this is singular, meaning it has no inverse? So think about all your definitions and how you're going to prove that. Okay, so we are trying to prove that it has no inverse, right? So I'm going to kind of give you some hints. Okay, so whenever someone wants you to prove something, you always want to prove that the thing you want is not true. Okay, so you want to prove that there's no inverse, then you have to prove that you cannot even have an inverse, right? So you think about it and say, like, what will happen if it does have an inverse? What will happen if it does have inverse? Then you have to prove that the way to make an inverse does not happen. Okay, so what happens if it does have an inverse? Let's say, okay, so this is matrix A, right? Let's say B is the inverse of A. Let's just say there is a matrix that does exist. What will have to happen between A and B? They have to be inverse of each other, or what? Okay, yeah, but maybe a few more lines before that. If A and B are really inverse of each other, then you multiply them together, you have to get what? Huh? Identity. Okay. All right. So if they are inverse, then when you multiply them together, you have to get identity, right? Do we know what B is? No, we don't know what B is, right? We don't know what an inverse matrix is. Let's just call it whatever we want, A, B, C, D. Right? Okay, A times B has to equal 1, 0, 0, 1. Okay, this is the big hint. So now you guys figure out how you're going to prove this. So give B some random variables, because if we don't know, just give them random variables and check from there. Okay, so the biggest hint is you do multiply A and B together. All right, A is 6, 3, 2, 1. B is A, B, C, D. We're trying to multiply them together so that we do get, 1, 0, 0, 1. So you have to use that to prove that it won't work. Okay, so if you do multiply them together, you should get 6a plus 3c in the first element, and then 6b plus 3d, 2a plus c, and then 2b plus d. And then remember, all those elements have to equal 1, 0, 0, 1 if you do want to inverse. So that actually means we have 4 equations. 6a plus 3c equals 1. 6b plus 3d equals 0. 2a plus c equals 0. And then 2b plus d equals 1. You just need to, from these 4 equations, prove that it actually won't work. It won't help you find A, B, C, D that actually make this B matrix. You have 4 variables, 4 equations. It's possible to solve. Okay, try it. So you have 4 equations and 4 unknowns. It is possible to solve. Now you want to just kind of look at it for a second here. You can see this one, these two both have A and C. And the interesting thing is that the first equation is actually triple of the second equation, meaning if you just multiply by 3, you should get the first one. However, if you multiply by 3, this part is still 0, which causes this to be an inconsistent solution. Right? You basically have this. That is not possible. You basically have the same thing, but they equal different numbers. It's inconsistent. There's no solution. So this is no solution. That's why there is no inverse. Okay, that was not satisfying. It looks like you guys very tired. So yes, that's where we're gonna stop today.